All right, so now that we can find the general term, determine if a sequence is geometric, and then use the general term to determine any value of a term number, one thing we also need to be able to do is generate terms of a sequence if we're given an equation for the general term. So if we need to generate the first 5 terms given, t sub n equals 5 times negative 7 to the power of n minus 1, we need to be able to do that. So we know that t1, in this case, would equal 5 times negative 7 to the power of 1 minus 1. And that means that we have 5 times negative 7 to the power of 0. We know that anytime we have a number to the power of 0, it equals 1. So in this case, the first term would be equivalent to 5. We know that for t2, it's going to be 5 times negative 7 to the power of 2 minus 1. So now we have 5 times negative 7 to the power of 1. And we know that anytime we have anything to the power of 1, the number remains itself. So in this case, it's 5 times negative 7. It's going to give us a negative 35. And you'll note that our first term was positive, but our second term is negative. And that's because of the value of the exponent on our negative 7. So t sub 3, so our third term, is equivalent to 5 times negative 7 to the power of 3 minus 1. So that's going to be 5 times negative 7 to the power of 2. So negative 7 squared times 5 gives us 245. T4 is equivalent to 5 times negative 7 to the power of 4 minus 1. 4 minus 1 gives us a cube, so negative 7 cubed times 5 gives us negative. It's going to alternate on us because of the exponent is increasing by 1. So negative 1,715. And then it asks us for all 5, so our fifth term is equal to 5 times negative 7 to the power of 5 minus 1. That equals negative 7 to the power of 4 times 5 gives us, and you guessed it, it's going to be positive. It's going to be 1,205. All right, so then we can write our sequence. We open our curly bracket. 5. I'm going to run out of room because I write very large. I'm sure you're better with a pencil than I am with a stylus. 245, and that I can't do that. That's just not conventional. I'm sorry. Wonder if I can write it down here. Open bracket. So 5, negative 35, 245. That's a horrible 4. It looks more like a Y. Negative 1715, and I still can't do it because I just don't have enough. Can't go any further over because then it pulls up weird things. So I'm going to write in a different color. And I'm going to write it over here. So we open our bracket. We have our 5, comma, negative 35, comma, 245. Too close to the bottom. My commas aren't really showing up. Negative 1715, comma, to go uphill to go over my little tab. And then our last one is 12,005. And we know that we could continue to generate terms with no problem. So that's what the ... means. The sequence continues on. That's if it's an infinite sequence. An infinite sequence continues on forever. A finite sequence has an ending. So if for some reason there was only 5 terms, then we wouldn't have the ... Our sequence would end with 12,005. But because it said the first 5 terms, we know that the sequence is going to continue on. So there. And that's how we use the general term to generate terms in a geometric sequence.